Chapter 9, Exercise 17, is asking you to find the final concentration of a few dilutions. So you would know that you were doing this type of problem by a couple key words. One is if you add pure water. So if you see the words added water, that's a sign that you're doing dilution. And the other sign is the word diluted. That means you're doing a dilution. So with dilutions, you're adding more solvent. And the solvent is usually water, so that the concentration of something goes down. Now, there's a pretty straightforward equation to use anytime you do a dilution. The equation is C1 V1 equals C2 V2. And the C1 stands for the initial concentration. So that's because it's a concentration that it's C. C2 is the final concentration after the dilution, after you've added water. V1 is the initial volume. And it's the V that's giving it volume. That's a sign that it's volume. And V2 is the final volume. Okay, so here's the strategy with this type of a problem. Look for the key words, added to water or diluted. Once you see those key words, write down this formula. Only then are you ready to go through the problem. Now, also actually, one other thing you'd like to do is to write each of those terms separately so that as you read through the problem, you can organize the numbers you come across. So C1, V1, C2, and V2. Okay, so for these, now we're ready to read through the problem. Every time we come across a number, we'll try to organize it based on this scheme. So we have 2 liters. That is the first volume that they're giving us. So 2 liters of a 6 molar solution. Now 6 molar, that's the unit for concentration. And you can put any units in for C1. You just have to make sure that they're going to be the same units that you get out, so you have to make sure that they're what you want when you get out. And then they want to know the final concentration. The final concentration, so that is what we're looking for. And they don't give us preferred units, so we might as well just get it in molarity. And then the last number they give us is it's added to water so that the final volume is 6 liters. So that's the last volume that they give us. And so we can take this and plug it into our equation. Our equation was C1V1 equals C2V2. And so underneath C1, we can write 6. And we should also make sure the units match. We have molarity and molarity, so that's good. And then we have liters and liters, so those are good. Okay, so instead of C1, we can write 6. Instead of V1, we can write 2. So then we have the equal sign. Instead of C2, we can write, well, just keep it C2 because that's what we're solving for. And then instead of V2, we can write 6. So what we have here is 12 equals C2 times 6. Divide both sides by 6, cancels on the right, and you have C2 equals 12 divided by 6, that's 2. And because we plugged in molar, we're going to get molar out, so 2 molar. So the concentration after the dilution is 2 molar. Okay, similar procedure down here. It says water is added to 0.5 liters, okay, lots of numbers and things, but then I see the key word, diluted. And instantly when I see that key word, before I keep reading the problem, before I try analyzing the problem, I take this formula and I write it down. C1V1 equals C2V2. That's the dilution equation. Not only that, but I take each of those variables and I write those on the side so that as I read through the problem, I can organize any numbers I come across. Okay, so now I'm ready to read through the problem rigorously. So every time I come across a number, I'm going to try to organize it according to this scheme. So it says water is added to 0.5 liters. Okay, that's the first volume that they're giving me, 0.5 liters, of a 12 molar sodium hydroxide solution. 12 molar is the first concentration that they're giving me. To make 3 liters, that's the second volume they're giving me, of a diluted NaOH solution. And again, in all of these, what they're asking for is the final concentration. The question says, calculate the final concentration. So again, we want to know that. And they don't give us a unit that they want it in, so we might as well just get it in molarity. Now before we plug it in, we want to make sure the units match. Molar and molar, that's good. And then liters and liters, so that's good. So instead of C1, we can write 12. So we'll have 12. Instead of V1, we can write 0.5. We have the equal sign. C2, because we don't know what it is, we'll keep it as the letter C2. And then V2, we can see is 3. So we'll write 3 there. Okay, on the left side, 12 times 0.5, that's 6, equals C2 times 3. To get C2 by itself, right now it's being tied to the 3 through multiplication. So to untie it, you do the opposite operation, division, with the same number. If you do that to one side, you have to do it to the other. It cancels on the right, and you're left with C2 equals 6 divided by 3, that's 2. And because we plugged in molar for C1, we're going to get molar out, or molarity out. So we'll have 2 molar is going to be the final concentration for this one. All right, how about C? You read through the problem, lots of numbers and units, and it looks really crazy, but then you see a key word, like a light shining in the dark. And the key word is diluted. Whenever you see that keyword, that or added to water, you would immediately drop everything else and write down the dilution equation. Not only that, but you would also, on the side, write down all of the variables in that equation listed separately, so that when you go back and read through the problem, you can organize the numbers you run across. Okay, so it says, C says a 10 milliliter sample. That's our first, the first number they give us. Milliliters is a volume. That's the first volume they give us, so that's going to be V1, 10 milliliters. So 10 milliliter sample of a 25% mass volume, 25% mass volume solution. This is a concentration unit, the concentration unit most often used in hospitals. So that's the first concentration they're giving us, percent mass volume. Okay. And they say that's going to be diluted with water so that the final volume is 100 milliliters. So that's V2. And as usual, as with all of these, they are asking us to find the final concentration. So that's what we're solving for. And they don't ask for specific units, so we might as well solve for the units that we already have. Okay, so before we plug these in, we want to make sure that the units match. So we have percent mass volume and percent mass volume, so that's good. Then we have milliliters and milliliters, so that's good. All right, so instead of C1, we can write 25. Notice after you check that the units match, you can just plug in the numbers. Instead of V1, we can write 10. Then we have the equal sign. Instead of C2, we'll have C2 because we don't know what that is just yet. And then instead of V2, we could have 100 because V2 equals 100. All right, so 25 times 10, punch that into a calculator, you'd see that it's 250. So that equals C2 times 100. Now we want to get C2 by itself. Right now it's tied to the 100 through multiplication. So we're going to do the opposite operation to untie it, division, with the same number. And if we do that to one side, we have to do it to the other. It cancels on the right, and so we're left with C2 equals, and if you punch that into a calculator, 250 divided by 100, you would get 2.5. And the units for that will be the same units we plugged in, percent mass volume. And actually, let me write that more neatly, just to be a good example to you. So we'll plug that there. Okay, percent mass volume. Okay, so that is the concentration of the final solution after you do the dilution for that one. All right, last but not least, D. So we read through the problem, lots of numbers, lots of letters, crazy units of 50 milliliters, but then we see keywords added to water. Those keywords, like a light in the darkness, tell us that we should be using the dilution equation. You dilute stuff when you add water to it so it becomes less concentrated. Not only that, but you would want to write each of the variables in that equation separately to the side so that as you read through the problem, you can organize the numbers you come across. Okay, so the first number we see is, it says a 50 milliliter. Now milliliter is a volume, that's the first volume they're giving us, so that's going to be V1. So 50 milliliters. Sample of a 15% mass volume. So 15% mass volume, that is a concentration. It's the first concentration they're giving us, so 15% mass volume is C1. It says it's added to water to give a final volume of 250 milliliters. So that's V2, 250 milliliters. And remember, for all these problems in this in exercise 8 or 17, they're asking you to calculate the final concentration. So that is what we want to find here. They don't ask for specific units, so we might as well keep it percent mass volume. All right, before we plug this into the equation, we want to make sure the units match, percent mass volume and percent mass volume. That's good. Milliliters and milliliters, that's good. So we can plug it in. Instead of C1, we can write 15. Instead of V1, we can write 50. We have the equal sign. C2 is what we're solving for, so we'll keep that as a variable. And then V2, we could plug in 250. All right, so you would multiply the right side, or the left side, 15 times 50. 15 times 50 would be 15 times 50. 15 times 50 would be like suspense. 15 times 50 would be 750, so that's the left side. And that equals C2 times 250. Oops, 250. So we want the C2 by itself. Right now it's tied to the 250 through multiplication, so to untie it, we'll do the opposite operation, division, with the same number. If you do that to one side, you have to do it to the other. 250 cancels on the right, and we're left with C2 equals 750 divided by 250, and that would be 3. So C2 would be 3, and remember the units for this, because we plugged in percent mass volume, that's the unit we're going to get out. So we'll have percent mass volume. And so that would be the concentration after you've done the dilution. So the general procedure for questions or exercises like exercise 17 is to look for keywords added to water or diluted, then write the formula down, then organize the variables on the left, read through the problem, organize those, make sure the units match, and plug them in and solve. And that's how you can find the concentration of a diluted solution.